Hi guys, welcome to Tutes Online. Today we'll be using mesh analysis to analyze a circuit. So mesh analysis is generally used to find the current in a circuit, and it does this with the use of Kirchhoff's voltage law. So if we had a circuit where this is 9 volts, this is a 12 volt, and we've got resistors of 1 ohm, 2 ohm and 3 ohm. To do mesh analysis on a circuit, what we need to look at is the loops in the circuit. So you can see there's 2 loops here. What we do is we choose a direction for the current. So generally you choose clockwise, but it's really up to you. So what we're saying is the current's going clockwise here and clockwise here through the circuit. And we'll call this I1 and I2. So once we've done that, we need to apply KVL. And for our first loop, the current is going clockwise, so through the voltage source here, we'll be going from negative to positive. So that means we'll be talking about a negative voltage. For the next element, the 1 ohm resistor, we've defined the current to go clockwise, so what we're essentially saying is that the potential difference is going from positive to negative. And so in our equation we'd write 1 ohm times by the current, which is I1, so that's just V equals IR. And for the final one, the 2 ohm resistor, you can see that the loop here is going through the resistor, but also this loop here is going through it. But with reference to loop 1, so on this side the current's going down, but on this side it's going up. So with reference to I1, this would be I1 minus I2 times by the resistance. And KVL says the summation of voltages in a loop will be equal to 0. So we'll expand this. We've got minus 9 plus 1 times by I1 plus 2I1 minus 2I2 equals 0. And so we get 3I1 minus 2I2 equals 9. So we'll call this equation 1. Now for our second loop, we'll do the KVL for that. So we've got the currents going through this resistor here, and we're taking it with reference to I2. So now we have I2 minus I1 times by 2 ohms. And the current going through the 3 ohm resistor is I2 times by 3 ohms. And we're going from positive to negative, so this is a positive voltage now. So it's plus 12 volts. And this will be equal to 0. So expanding this, you get 2I2 minus 2I1 plus 3I2 plus 12 equals 0. And this simplifies to 5I2 minus 2I1 equals negative 12. And we'll call this one equation 2. So now we have 2 unknowns and 2 equations. There's a few ways to solve this, but I'll use substitution. So going from equation 2, this can be arranged to say 2I1 equals 12 plus 5I2, which leads to I1 equals 6 plus 5 on 2I2. So now we have an equation for I1. So we'll call this 3. We'll put equation 3 into equation 1, and we'll get 3 times by 6 plus 5 on 2 I2, so we substitute for I1, minus 2I2 equals 9. Expanding this, we get 18 plus 15 on 2I2 minus 2I2 equals 9, which simplifies to 11 on 2I2 equals negative 9, or I2 equals negative 18 on 11, which is about 1.64 amps. So if we substitute this value, which we'll call 4, into our equation 2, so that's 4 into 2, we get negative 90 over 11 minus 2I1 equals negative 12, and this leads to the value I1 equals 21 over 11, which equals about 1.91 amps. And so that's our solution. We've found the two current values for these two loops in the circuit, I1 and I2. So that's it from me. If you have any questions, post a comment. Please subscribe and visit the website. Thanks.